look at the topographic profiles for Australia and New Zealand using our geocontext profiler from geocontext.org. And so here we have Australia, and so I've gone from A to B. So essentially from the northwest coast to the very highly populated southeastern coast. And we can see through here we have the coast, of course we have the abrupt coastline, and then throughout much of the outback it's actually pretty elevated. I'll come back to a very certain physical feature in central Australia here, deep within the Aboriginal territories, where we have also the outback, very rugged, very dry, but also elevated. But for the most part, this is a relatively flat continent. If we're looking at the topographic profile, we don't see much elevation change. I mean, that's just 1,000 meters, nothing like what we would see in South Asia or East Asia, the dramatic increase as we get closer to the Himalayas. It just dwarfs these elevation changes considerably. We have that interior part of Australia, kind of this, what they would refer to as a basin, or this low-lying area, also fairly lightly populated for similar reasons. It's so stinking dry, so stinking hot in the summertime. But then eventually here we get to the Great Dividing Range, or the Eastern Highlands, where we see definitely greener in terms of the colors here on the aerial map. And so greener means definitely we're going to get more precipitation, so we get some orographic precipitation network. Even here in parts we can find some snowfall in parts up in the elevated areas, of course, during the winter time. Now let's go to a particular area just off the northeastern coast of Australia, and that is the Great Barrier Reef. And one of the things I mentioned with the Great Barrier Reef is it's formed in very shallow areas. And so coral reef here in the Coral Sea, very cleverly named, it really only finds in certain areas where we have this perfect situation where very shallow water. Shallow, why does that matter? So sunlight can actually reach the various critters and living organisms in the Great Barrier Reef, and so thus photosynthesis can occur. And so we see this very low-lying area where you also get a good amount of sunlight. So there's the Great Barrier Reef, very fragile, so it's slowly kind of being depleted, especially as much of these touristy towns, tourists come out there and frolic and do all kinds of damage to the Great Barrier Reef. Now let's go to that very, like I said earlier, that central area, the Aboriginal area. I'll go ahead and zoom in, and here we have what's called Ayers Rock, but actually probably a preferred term would be Uluru, U-L-U-R-U. This essentially is an example of a monolith, or this big huge mountain or island mountain that's kind of stuck all by itself. And just think of this as just the Chuck Norris of rock. It's over time been able to withstand, it's this really tough, really strong rock. It's been able to withstand erosion. Keep in mind, a massive amount of erosion has happened throughout much of Australia because it's been all on its own, traveling all by itself on top of a tectonic plate, in which wind and rain and all kinds of different things that erode and remove material has done its number. But not to this particular rock here. It's been able to fight off that, and it's actually a certain material, certain type of rock that's been able to withstand a lot of that erosion. This is a touristy location. A lot of people come out here and climb it. And like I said beforehand, it's very sacred to the Aboriginals that live in this particular area, the natives. Also, we have New Zealand we got to talk about. In New Zealand, here was two different islands. Both of them we can see ruggedness. We'll just start off with the South Island. And what's going on here is a very interesting pattern. So we have on one side the Australian plate, and on the other side the Pacific plate. In the case of the South Island, what we can see is the Australian plate is actually going underneath, and thus is lower than the Pacific plate. You can see how the Pacific plate is up higher, and so essentially what's happening is the Australian plate is being forced underneath that. So what's happening here is we get a lot of volcanic activity right along here as that material is being forced underneath, then is being being heated up, and then thus forming pipelines as far as magma reaching the surface and eventually forming rugged terrain, but also volcanoes. So we can see that particular pattern. Once again, the Australian plate plunging underneath the Pacific plate. That's going to be different than what we'd see with the North Island. So the North Island now, the Pacific plate is plunging underneath the Australian plate. So a very interesting pattern here. We can see the depth of this particular plate. Now on this side, the Pacific plate's deeper than the other side, the Australian plate. So this is kind of an interesting pattern we see in the case of New Zealand, in which it's essentially got these two different plate convergence situations. One in which the Australian plate is plunging underneath the Pacific plate, and then the inverse for that for the North Island.